Hello students. So in this video we are going to start chapter 7, that is study of gas laws, and this will be the last chapter because in the reduced syllabus chapter 8 atmosphere is not there, so this will be our last chapter. Okay, so first we will understand what is gas. As we all know that matters available in three states, they are solid, liquid and gas. In this chapter we will discuss mainly about gas and what are their properties. So the first property of gas is that gases do not have definite shape or definite volume. Okay, we know that liquid and solid are having definite volume, but gases do not have a definite shape or definite volume. Next, the distance between the molecules is very large in case of gases. That means intermolecular spaces is very large. The gap or the space between the molecule is very large. Third property of gas is the force of attraction between the molecule is negligible. That is very less. So intermolecular force of attraction is very less, or we can say negligible, means nearer to zero, but not exactly zero, but it is very near to zero. And the fourth property is molecules of a gas move in straight lines, undergo random collision with other molecules and occupy the complete space available in the container. So the molecules of a gas are, they always move, they are in random motion, continuous random motion, but they always move in straight lines. Why they move in straight lines? And because of that they hit with each other, collision occurs with other molecules. So these are the four properties of gases. Okay, now we'll see why these properties are there, what are the reason. To explain these properties we'll take the help of kinetic theory. Yes, all these properties can be explained by using kinetic theory. Okay, so let us see the first one. What does the first one say? That gases do not have definite shape or volume. Now why? Because molecules in a gas are far apart and the force of attraction between the gas is very weak. Since very weak attraction of force and the molecules are very far, so they does not have any volume or shape. Next, gases are highly compressible, or they can be compressed very easily. Why? Because the reason is that volume of particles negligible compared to the intermolecular distance. So the volume of the particle is very less as compared to the distance. So they can be compressed very easily. Since the particles are far away from each other, so they can be compressed. Third point, that exert pressure in all direction. So gas molecules exert pressure in all direction. What is the reason? Because impact of gas molecules with high velocity causes pressure to be exerted on the walls. Now if the particles will move with each other, they will hit with each other and they will hit with the container wall also. So pressure will be exerted on the wall of the container. Let us see the next one. Next one is gases have low density. So what is the reason for that? The intermolecular distance between the particles of gases is very large. So since the particles are very far from each other, so very less number of particles will be there per unit volume. So pressure will be, so density will be very less. Next, diffusibility or miscibility. Now what is diffusibility? Diffusibility means which can mix with each other. Okay, so gases diffuse readily and when kept in contact with one another combine completely, forming a homogeneous mixture. So gases mixed with each other very easily. What is the reason? The reason is that the space between the molecules of gases is very large since the intermolecular distance between the gas molecule is large. Since the intermolecular space is very large, so any gases can very easily mixed with each other. So these are the kinetic theory reason for the property of the gases. Next we will see gas laws. Okay, but before understanding gas laws, we have to understand some parameters which we check. Okay, so for gas, three parameters we should know. The first parameter is temperature. So what is temperature? It is an indicator of the average kinetic energy possessed by a molecule. That means temperature is nothing but the average kinetic energy of a molecule of gas. Okay, what is kinetic energy? Whenever a particle moves, it gets some kinetic energy, and we know that in gas particles always move, so always the particle will be having kinetic energy. Now that kinetic energy is nothing but the temperature which it shows. So temperature is nothing but the indicator of the kinetic energy. Next is pressure. So what is the unit of temperature? So two units are there. One is Celsius temperature, that is symbol is degree Celsius. Next one is Kelvin temperatures, symbol is capital K. Remember that. Okay. Now if you want to convert Kelvin to degree Celsius, we have to add 273. So remember that Kelvin is equal to degree Celsius plus 273. But if you want to convert degree Celsius to Kelvin, then we can write that Kelvin minus 273. Remember that. So if we want to convert from degree Celsius to Kelvin, you have to subtract 273. If you want to convert Kelvin to degree Celsius, you have to add 273. Why it is so, we will understand in the next part. Next is, what is pressure? So pressure is the average force exerted. Pressure is the average force exerted by bombardment of gas molecules on the walls of a container per unit area. Okay, so what is pressure? Pressure is the force exerted by the gas molecules on the walls of a container per unit area. Now what is the unit? So unit for pressure is atmosphere. Next one is centimeter mercury or millimeter mercury, torr, or so these are the three units. Now remember, if you want to convert, so 1 atmospheric pressure is equal to 76 mercury or 760 millimeter of mercury. Okay, and 1 millimeter of mercury is also known as 1 torr. So this you have to remember. Okay, next is volume. So what is volume? Gases have indefinite expandability and occupy the volume of the container. Yes, remember, suppose we are having a very small tube and inside that some gas is there. Same, suppose 5 ml gas is there inside that tube. Now same, if you want to keep it in a very big size cylinder, suppose it is a very big cylinder, inside that also same 5 ml gas can be occupied. Sorry, here it will be not 5 ml, let us assume it as a 5 gram. Suppose 5 gram gas is there. Now volume here is very small one, so it is 10 ml. And here also same 5 gram gas can be occupied. Same 5 gram gas can be occupied. Suppose it is having 100 ml. So if the volume different, but the same gas can occupy different volumes. Why? Because gas does not have a definite volume. Okay. Next, so what is the unit of volume? So unit of volume is liter. Just a minute. So to remember that 1 liter is equal to 1 decimeter cube, and that is equal to 1000 cubic centimeter, and 1 decimeter cube is equal to 1000 cubic centimeter, so that is equal to 1000 ml. So 1 centimeter cube is equal to 1 ml, and we know that 1 ml is equal to 1 ml is nothing but milliliter, and L means liter. Remember the symbol. Milliliter symbol is small m and small l, and liter symbol is small l. Cc means cubic centimeter, and dm cube means cubic decimeter. So you have to remember all this conversion. What is the conversion? Let us recap once again, that 1 Kelvin is equal to how much? 0 degree Celsius plus 273 Kelvin. If you want to convert degree Celsius to Kelvin, then you have to subtract minus 273. Okay. Then 1 atmospheric pressure is equal to 76 centimeter of mercury or 760 millimeter of mercury, and 1 millimeter of mercury is equal to 1 torr. Then in case of volume, 1 liter is equal to 1 decimeter cube, and that is equal to 1000 cubic centimeter, and 1000 cubic centimeter is equal to 1000 ml. So 1 cubic centimeter is equal to 1 ml. Okay, all this you have to remember. Make it note, whatever I am underlining, all these things you have to note it down in your copy. Okay. Next is gas laws. So first we will understand that which parameter is depending upon what. So first of all, pressure if we increase the pressure, then what will happen? So when the temperature of a fixed mass of gas is kept constant and pressure is increased systematically, the volume correspondingly decreases. So remember that if the temperature is fixed, then the pressure is, if the pressure will be increased, then volume will decrease. Let us take an example. Suppose a gas X occupies 500 ml, and at that time the pressure is 2 atmosphere and the volume is 250 ml. Then when the volume was 500 ml, the pressure was 2 atmosphere. So when the volume will be 250 ml, the pressure will become 4 atmosphere. Okay, so remember, if the volume decreases, then pressure increases. Remember, if the volume increases, then the pressure decreases. Clear? Now if the pressure will be decreased, then what will happen? So when the temperature of a fixed mass of gas is constant and if the pressure is decreased, then the volume will increase. Okay, so if the pressure is decreased to 1 atmosphere, then the volume will become 1000 ml. So remember that if the volume decreases, then the pressure increases. Clear? Okay. Next we will see that what is the relationship between temperature and volume. So if you remember that when the pressure of a fixed mass of gas is kept constant, then the temperature of the gas increases systematically and the volume correspondingly increases. Okay? So whenever the volume temperature is increased, then the volume also increase. Remember that. So what happens when the temperature is increased, then the volume also increases. You have to remember that. And if the temperature is decreased, then the volume also decreased. Remember this. Okay. So in case of pressure, what happens? Remember, if volume increases, then pressure decreases. That means they are inversely proportional. They are inversely proportional. So we can say that pressure and volume are inversely proportional. But in case of volume and temperature, they are directly proportional. That means if volume increases, then temperature also increase. Okay, we will continue in the next class.